Hey everyone, so our second video, we are now in the spiral. We're going to start chapter 2. I'm on page 39, and we're going to be graphing. How we graph in this chapter is going to spiral or repeat in all the chapters after that, so it's really important that you do watch this video. It's not too difficult in the end because you're just going to start and repeat a pattern over and over again. So in this chapter, we are mainly focusing on quadratic functions. And a quadratic function is just where the biggest exponent is a 2. But we're also going to be taking a look at cubic functions where the biggest exponent you see in our function is 3. So let's first get familiar with the shape. The idea is when I'm graphing something that I don't know the shape of, I want to pick some values for x that fit on the piece of graph paper that I'm working with and that are easy to work with. So that's why these numbers here have been chosen. All of these will fit on the graph paper on the right, and I'll be taking these numbers, plugging them in to my function, which is x squared, and getting my results so I can graph them. So if I take -3 and square it, I get 9. If I take -2 and square it, -2 times -2, I get 4. -1 squared is 1, and I'm just going to fill in the other numbers. So let's go ahead and graph those. So -3, 9. Let's see, 2 right there. And then I'm going to do -2, 4, -1, 1, 0, 0. Now I want you to realize that some of the y values are repeating. So what's happening here is because the y values are repeating, it will be failing the horizontal line test. So it's just going to be a function, not a one-to-one function. And now let's take a look at our cubic function. Again, these are the parent functions. These are the most basic ones. We will soon be adding what I wrote at the top, a, h, and k, and you're going to see these shapes stretch, compress, move left, move right, move up, move down. So now I'm going to cube the numbers. So -3 cubed, choosing the same values, this is probably not a good one to pick, is -27. So -3 times -3 times -3. That will not fit on the graph paper. -2 squared, so -2 times -2 times -2. -1 squared is -1, or not squared, cubed. 0 cubed is 0, and then here are the others. So since the -3 with the 27s don't fit, I actually will not be graphing those. So I can even scribble them out. And now I'm going to go to -2, 8. I'm sorry, -2, -8. 1, 2. I think that's about it. And then -1, -1. Didn't show up very well. 0, 0, 1, 1, and then 2, 8. All right, so I'm now going to connect my points on both of them. So this is the parent function for a quadratic. It's known as a parabola. And then here's my parent function for a cubic. So even though the graph paper is ending, the shape does not. And so that's why I'm putting arrows. So let's just learn about their domain and range and what type of function they are. So to do that, I'll mark my important points. It's going to the left and up. It's going to the right and up. And then this is where it turns, and it's also where it hits the x-axis. And then I'll do the same on the other one. So -infinity because it's going down, or left, and -infinity since it's going down. This arrow is going to the right, and it's going up. And then its other big point is 0, 0. So if you notice, we got the same information, pretty similar from the left picture to the right picture. All right, so what's the domain? Remember, this is where we scan. We scan from left to right, and you can't really see me doing this, but the smallest x value is -infinity. And if I keep scanning to the right, the biggest x value is infinity. Another way you can write it is that weird r, and you're going to see me start to use that a lot more than those infinities. The domain, now I scan from the bottom up using the y values. The smallest is this y value, and the biggest is any infinity at the top. Comma's a little big. I will include 0 because it is implied closed circle. It is part of the range. Let's go ahead and do our domain and range on the cubic. So again, scanning from left to right, this is my smallest x and this is my biggest x. So again, instead of writing the infinities, I'm going to start to use that r, meaning all real numbers. And then when I do the y values, scanning from the bottom to the top, this is my smallest y and this is my biggest y. So it's another all real numbers. All right, is it 1 to 1? I can see just from the table alone on the quadratic that x's repeat, so no, it's not 1 to 1. If you look at the picture, it is failing the HLT. The next one is 1 to 1 because none of those x or y values repeat. They're positive versus negative, but they're not the same numbers. So yes, because it passes the HLT. And you do have to realize that as we go through our ICANNs this year, we will be putting some spiraling in there. So we don't want to forget about domain and range and is it a function, what type, etc. All right, so let's start to look at what happens. The biggest thing that's going to be a little different than what we did in the last A is that how A is going to apply here. All right, I had to do a quick pause on that because my phone rang. Sorry about that. So real quick, we're going to really focus on how our stretch, that A value, applies. In our absolute value, we could use a shortcut where that A was our slope, like our rise over run. And that does not happen in quadratic and cubic functions. So what will happen here is that when we put A in there, if I can get this to highlight, we will have either our vertical stretch or compression. And if you see a negative, that just means that's a reflection, a flip, if that A value is less than 0. So just remember the negative means it flips. And then a reminder that if your A, let's see where I can write it. The negative means it will flip. If your A is bigger than 1, it will stretch. And if your A is then in between 0 and 1, it will compress. So when we do this and we get our A values, what we're going to do is that A value changes the Y value of our parent function. So I'm just going to put PF for parent function. So let me show you how we do that. And this is the first step when we start to graph them. We want to take a look at A, whether it's negative, it's bigger than 1, in between 0 and 1. So where I'm going to start, I'm going to go a little bit more left, is I'm going to make a table. It is your job to remember these values. So we're going to start with x squared. That's not a negative there. I don't know why it keeps doing this. With our parent function of, all right, so the values that we're going to use when we graph, we do not need to use all of these. I am satisfied if in both situations if we just leave out these 3's. Chances are, once we apply all the changes to it, those points wouldn't even fit on our graph paper. So you need to remember the x values that we're going to use, and these are going to pop up a lot this year. We're going to be using -2, -1, 0, 1, and 2. And the idea is I square these numbers, and when you square a number, a negative times a negative or a positive times a positive, you always get a positive value. So this is me squaring the numbers, and you have to know these numbers. All right, now what happens is since I have in this problem an A value of 2, this means it will stretch, which means when we graph it, it's actually going to look a little skinnier than what we saw up here. All right, so once you get that, what you're going to do is you're going to apply any stretch, compress, or flip to the Y values. So basically, I'm just going to take every Y value that I see here and multiply them by 2. And this 2 is, again, this 2 that you're seeing here. And when I do that, my Y value goes from 4 to 8, from 1 to 2. 0 still stays 0 from 1 to 2 and from 4 to 8. And then what I like to do is just very lightly kind of cross out the old y values because I have a new set of y values. So I'm going to graph these now. And instead of going to negative 2, 4, I'm going to go to negative 2, 8. And instead of going from negative 1, 1, I'll go from negative 1 and 2, 0, 0. And here's 1, 1 becomes 1, 2. And 2, 4 becomes 2, 8. And now when I connect these points, hopefully you can see this looks just a little skinnier than the one at the top. So again, all this stretch, compress, flip will be changing our y values. So let's go to the one on the right. Let's try another quadratic one. So again, I'll be making my table. All these things I expect you to do. And these are the x values we will be using. We're graphing the parent function, x squared, so I should be plugging these numbers in and squaring them. And again, why am I choosing these x values? Because you get to pick any x you want, but I'm picking these x values because they fit on my graph paper because of this x-axis, and when I square the values, those values fit here. So that, again, is why I'm choosing those numbers. So this one has a flip. So what we're going to see is this U-shape, this parabola, flip upside down. So it kind of looks more like a rolling hill than anything else. So I'm going to take all of these y values, and you can think of this as a negative sign, you can think of it as an opposite, but I will just take the opposite of what they are. So if I kind of make a new y column, 4 turns into negative 4, 1 turns into negative 1, 0 is still 0, and then I'll get my other values. And then again, what I like to do is cross out the old y values because I don't really need them anymore because I have new y values. So now I'm going to graph negative 2, negative 4, negative 1, 0, 0, and just finish up the rest. And the more you graph these, the better you get. Oh, it's a little off. You can graph them pretty fast. So this is what it would look like flipped. All right, let's take a look at a cubic one. So when we work with cubic, we will still work with the same x values. So that's kind of a nice thing. You don't have to memorize the x values for two different things. It'll be negative 2, negative 1, 0, 1, and 2. And then for the y values, I will be cubing them. Now, cubing a number is a little more difficult, I guess, I would say, than squaring a number. So you just have to think negative 2 cubed is negative 2 times negative 2, which is 4, and 4 times the other negative 2 is negative 8. Negative 1 cubed is negative 1 times negative 1, which is 1. Multiply that with another negative 1, and you get negative 1. 0 is 0, and then here are the other numbers. So let's take a look at what happens with this shape. So now what I have is a negative 3. The negative is going to flip it, and the 3 is going to stretch it because it's bigger than 1. So let's graph these points. Let's first apply our flip and our stretch. So I'm going to take all my y values and multiply them by that negative 3. So by negative 3, negative 3, I don't know why it's doing this, negative 3, negative 3, negative 3. And when I do that, I'll get all new y values. So unfortunately, I write much bigger on this than I do on regular paper with pencil or pen. So I'll have to spill into my graph over here. I'm going to get a positive 24, a positive 3, 0, negative 3, and negative 24. And just like before, since I have new y values, I'm going to cross out my old y values. And I would highly suggest you do crossing that out because sometimes we look at our graph, or I'm sorry, at our table, and we focus on the wrong columns and graph the wrong things. All right, so the 2's with the 24's are not going to fit. So instead, I'm going to go to negative 1, 3, 0, 0, and then 1 will have negative 3. And this shape, if you go back to this shape, notice